discussion for this day. And for today, we're going to talk about the continuation from our previous topic. Last time, we discussed on trigonometric integrals, diba? We talked about the trigonometric integrals involving the powers of sines and cosines, the seconds and tangents, and also those with differing angles of our sine and cosine. So that is for the trigonometric integrals part. Now, we're going to discuss on the trigonometric substitution. So that's why we have an emphasis on the trigonometric substitution. Okay, so without further ado, let's continue our discussion on trigonometric substitution. So what are these trigonometric substitutions? So trigonometric substitution is to be used to evaluate integrals involving the radicals. So mo ni siya ito ang purpose, no? This is used to evaluate integrals involving the radicals. So like this one, and this one shown here and this one. So we have here the square root of a squared minus u squared, the square root of a squared plus u squared, and the square root of u squared minus a squared. So the objective, the main reason why we're going to use the trigonometric integrals substitution is to eliminate the radical. So as you can see, we have these radical signs. Sometimes there are radical signs in the integral, and then we need to remove that, or we need to simplify the given integral. No, mo na siya kuan pinaka ginabuhat yun, no? Simplify first, and then solve it. So, kung saan mo ni siya magamit, when we are going to use the trigonometric substitution in eliminating the integral, we are going to use the trigonometric substitution if none of the basic integration rules applies. Of course, you'll only use this one, the trigonometric substitution, if none of the basic integration rule applies. So if you notice in you know that this is kind of similar with our inverse trigonometric function, diba? But uh, if magamit yung inverse trigonometric function in a given integral, then you're going to use that one. But this one, there are certain cases, no, or problems or integrals or differential equations in such a way that we cannot use the inverse trigonometric integral rules. And here we're going to remove those, and we eliminate the radical signs by using trigonometric substitution. So we have three equations here. Here's nakita na to. Oh, are going to remove the trigonometric the radical signs. So we are going to remove the radical signs in the integral by using the Pythagorean identities. So take note of this one. Kanina din siya to ang magbalik-balik kaning tulo. We have the cosine squared of theta is equal to 1 minus sine squared of theta. We also have here, no, secant squared theta is equal to 1 plus tangent squared theta, and tangent squared theta is equal to secant squared theta minus 1. So, duha ra ka formula itong gamit diri. We have the Pythagorean na sine squared plus cosine squared is equal to 1, and then the tangent squared theta plus 1 is equal to secant squared theta. And then nato lang siya transpose. Okay. So for the first one, first radical, diba, we have the square root of a squared minus u squared. Again, a is any number, and it should be greater than 0. And u is any variable. Now, for the given, if we are given a radical, no, with in this form, having a form of square root of a squared minus u squared, then we let u is equal to a sine theta, where our theta, the value of our theta is greater than or equal to negative pi over 2, but less than or equal to pi over 2. Okay, remember that this is, we're using here trigonometric substitution, and the value of our angle here, or theta, is in radians. Okay, so if we let our u as a sine theta, if we substitute that one, then we can obtain the square root of, we have here the a squared minus u squared. So u squared, we will have a sine theta squared. We just continue the process. We have the a squared minus a squared, and then sine squared theta We don't forget the square root. And then, if you notice now, we have the a squared. Si a squared, pwede natin na siya ipagawas. Then, we will have 1 minus sine squared theta, di ba? That is a trigonometric, or we have this Pythagorean identity. So, the square root of a, can let that out. Then, we will have the remaining 1 minus sine squared theta. Now, how can we remove the radical sign? We know that 1 minus sine squared theta is equal to cosine squared theta. And square root of cosine squared theta, that is just the cosine theta. So, for if we have any value, if we have a differential equation in the form square root of a squared minus u squared, provided that other basic integration rules cannot be applied or cannot be used, that is just equal to automatically a as a cosine theta. And along that is the first case in our three radicals here. Next, we have this is quite similar with the first one, pero that is just plus. So we have here the square root of a squared plus u squared. Again, we just substitute u with the given a tangent theta. A tangent theta squared. And then this is just same story as the earlier. We have then this one. And common term is the a squared and the square root of a squared, that is just a. Then we have here the 1 plus tangent square theta inside the radical. So that is just equal to secant squared theta, or simply a secant theta. So if you see any radical in the form a squared plus u squared, again, this will be only applied if no basic integration rules can be used in solving the given differential equation. So automatically, that is just equal to a secant theta. Now for our third radical, we have in the form square root of u squared minus a squared. So we let our u as our a secant theta squared minus a squared. Okay, so this becomes square root of a squared secant squared theta minus a squared. So a squared is our common factor, and then we take the root out. Then you'll have secant squared theta minus 1. So that is equal to the tangent squared of theta, or simply a tangent theta. Okay, so we'll have, then we will know that the square root of u squared minus a squared is just equal to a tangent theta. So we remove the radical sign, and what remain is just the trigonometric function. Okay, so this is a summary of what we discussed earlier. Now, if we have the square root of a squared minus u squared, so if kung nyo tanaw mura siya in the form 1 minus sine squared theta. So automatic that a is equal to, the u is equal to a sine theta. Here, for our square root of a squared plus u squared, if manotice ninyo, that is quite in the form 1 plus tangent squared theta. Diba? So automatically, our u will be a tangent theta. And for the last one, this is also quite familiar. It looks like a secant squared theta minus 1. So that's why we're going to use as the substitute for u is equal to a secant theta. So this is trigonometric substitution. And then, so sa maning mga right triangles on the right. So if you notice, no, we have the sine theta value here. So then we have the u is equal to sine theta. If you're going to rewrite that one, we'll have sine theta is equal to u over a. You know that theta is an angle, and sine This is a sign identity. So if we have a right triangle, and then we have our theta here, so we know that the sine is the opposite over hypotenuse. That's why we have here our u is as the opposite of our angle theta, and the hypotenuse is a. Same thing that applies here with our tangent. If we rewrite that one, we'll have tangent theta is equal to u over a, and that is just opposite over adjacent. So the opposite of the theta is u, and then adjacent is the a. And then we have our hypotenuse here. On this side, we have also the adjacent part that is just the square of the hypotenuse minus the square of the one line. And for the last part, we have here the second theta that is, you can write that as u over a. And we know that the second identity is equal to hypotenuse. So we have here our hypotenuse as u over adjacent a. And the unknown part, so is just the square of the hypotenuse minus the square of the second leg. Now, keep in mind that for the third type, no, kaning square root of u squared minus a squared, uh, if we look back from the last one, that is a tangent squared theta, and we know that uh, if we extract the root of the square or the square root, we will have two values. We have the positive and the negative. So here, we have a positive a tangent theta and then a negative tangent a, say, a negative a tangent theta. So when we're going to use the a tangent theta and then the negative a tangent theta, if our u is greater than a, or our angle is greater than or equal to 0 but less than 5 or 2, then we are going to use the value of square root of u squared minus a squared to a tangent theta. Else, if u is less than the negative a, or the angle of our right triangle is less than pi over 2, but greater than or equal to pi, then we are going to use the value or the equivalent value of our square root of u squared minus a squared into negative a tangent